Critical minerals fundamentally underpin everything that we do every day. It's in your phone, you have Veris in your AirPods, your screens, your laptops, everything that we use, how they're refined and how they're mined, that all happens in the background.
This is the intersection of geopolitical urgency and tech.
We need a lot of aluminum, we need an insane amount of copper, we need more iron, we need more zinc.
Now we have technology that can actually go and disrupt this. Hard tech companies working in sort of dirty spaces, willing to go out in the field.
There's not that many massive markets left that have been sort of like largely untapped by technology, and mining sort of screams one of the largest markets in the world.
So now's the time to build this company.
So Turner, you're coming out of stealth with $85 million raised. Why don't we get into what are critical minerals and why do they matter?
Critical minerals fundamentally underpin everything that we do every day. And that's why we're personally really excited about it. But it's not just aerospace, energy, renewable energy, battery energy storage systems, the massive growth in AI that's happened in the last 12, 18, 24 months. It's also, and defense, obviously, but it's also everything that we use every day, right? Like you have rare earths in your phone, you have rare earths in your AirPods, your screens, your laptops. And so it really does, it like crosses everything that we use. But where they're produced and how they're refined and how they're mined, that all happens in the background. And so it's something that really does need to be brought to the foreground, something that we need to support more and more of. It's a long chain to go from digging something up to go all the way through to something that can actually be deployed in an end product. And so excited to talk about that.
Well, I want to get into how do we turn rocks into batteries or magnets and why is that so important?
Yeah, so it starts with mining, obviously. Well, it actually starts with exploration. But
you got to find the rocks in the first place.
That's right. You got to find the rocks in the first place, which is hard to do. And there's a lot of awesome companies that are working on trying to condense that timeline. But once you do find them, you have to get that asset or that resource permitted to extract. You develop a mining plan. You have to mine it. And when those rocks come to the surface, you have to separate ore from waste, which is something that is not as trivial as people might expect. And then you go through a concentration step. So the ores will come to the surface. They'll be, less than 1%, definitely less than 5% concentration, unless you have this world-class deposit. And you'll typically go through a concentrating step. So that can be mechanical, it can be thermal, it can be chemical, and that gives you an intermediate product. And those intermediate products kind of move all over the world and typically go to refining assets. The refining operation effectively goes from anything that is like a 10% concentrate to a 50% intermediate product and turns into a high purity metal. And then you go into a specialty chemical. And so that's this intermediate product where you go through another chemical process to either make a metal sulfate or a metal hydroxide salt. And then you will convert that into an engineered material, which is the next step. And that, in electrochemical systems and batteries, you'll have cathode materials, you have anode materials, and there the morphology and the electrochemical performance in the system is really important. And then you're ready to deploy into a battery cell. And then you'll go into a module, and then you'll go into a pack, and then you'll go into a car, or go into a stationary storage product. And on the magnet side of things, similarly, you'll get to a refined rare earth product. And it's a long list of rare earths. They often get bundled into like one group, but it's important to kind of like break them out. And then the common way of making magnets, there's a few flow sheets, but you'll slurry it. You'll get the right blend of the different rare earths that you're trying to put in. You'll cast that. You'll sinter it, and then you'll go through a fairly intricate and like high precision machining process to get the geometry that you want with the tolerances that you need before you can deploy that into magnets and eventually into motors.
How specific is it for a given site, given like concentration and other sort of waste products? Like how dynamic is it? Like is one rare earth mine going to be similar process to another, or is there going to be very sort of bespoke setup?
Yeah, it's very bespoke. And it's actually part of the problem, and what makes kind of the minerals industry so complicated is that the flow sheet, which is ultimately how you go from the ore all the way through to the refined metal, is designed for that specific asset. You will have concentrations of impurities that you have to manage. The concentration, obviously, of the target metal is different. And there's like a library of metallurgical unit operations that are kind of all stitched together to build a refining operation or a processing operation. But how those are stitched together, that's bespoke for the individual unit operation, and tied to the kind of chemical metallurgist, process engineer that designed the circuit in the first place. So there's a lot of like human impact on what that flow sheet ultimately looks like. But yes.
And I imagine
bespoke.
very hard to change as the nature of the ore changes as you mine a site.
That's right. And so, part of what we're working on and what we'll talk about a little bit later, I'm sure, is how do you define circuits or design circuits that have a little bit more flexibility to be able to process ore as it changes over time as you mine through the ore body. Because one mine does not actually have consistent ore coming out of it. The earth is heterogeneous. The ore grades are changing. The impurity concentrations are changing. There are different ore zones that have different properties in how they are floated or how they're concentrated, how they perform in a leaching circuit. And all of those things are kind of custom built for a specific asset.
One more question on this. Like what are the types of job titles, like backgrounds of people working in this space? I imagine for, at the supply chain you just described, it's very different types of people, very different backgrounds, but they all have to ultimately work together. But could you talk a little bit about that?
Yeah, that's one of the big hard parts is you have geologists, you have geophysicists, you'll have mining engineers, you'll have geotechnical engineers, you'll have process engineers, chemical engineers, chemists, metallurgists, mechanical engineers, structural engineers, civil engineers. It's the whole gambit.
Plus the long tail of, workers on site who are moving things from point A to point B.
That's right, which also have a super diverse skill set because you need everything from the mining engineers and the chemical engineers and the geologists that sit around to operate the asset, in addition to the folks that have to kind of manage the back office, which is something that often gets overlooked when we're thinking about successfully building and operating a complex circuit.
Did you always love rocks? Like, did you always know that you were going to start a mining company?
Yeah. So funny, kind of a funny story. The day that I graduated from college, the urge that I had was to just move to Australia and try to find a job in a mine. I did not act on that urge, and instead started at Tesla roughly 10 years ago now. And I started out working on factory design, factory construction, and actually slowly over that 9+ year period, worked my way upstream in the value chain. So worked on factory design and construction, then started working on battery cell manufacturing. Spent a lot of time in Japan with Panasonic, who's our primary battery cell manufacturing partner, working on incremental improvements to their legacy battery cell manufacturing systems. The pull has always been big things for me, like large scale infrastructure that has a large impact on the world. And if you want to have a big impact on the world, you have to build things at scale. That's how you get to impact. But yeah, so I was working on battery cell manufacturing. Because I was spending a lot of time in Asia, started to explore the supply chain, was building some of the early techno-economic models of how cathode materials are made, how anode materials are made, and the balance of the components that go into a battery cell. And ultimately, this was just following cost. It was, when I was working on factory design and construction, the most expensive thing was actually the equipment that goes inside the factory. Then when we started working on cell manufacturing, kind of realized that the expensive part of making cells is the stuff that goes inside the cells. And then as you start getting further and further upstream, you realize that the primary driver of cost is the metals that are going into the engineered materials that then go into the cells and then eventually go into the battery. And so started kind of digging much deeper into why metals are so expensive. And what you kind of run into is that there's this interesting incentive misalignment that exists between the customer and the producer of metals. Like in the mining industry, more demand, this is totally different than manufacturing. More demand, if you have a higher volume, the expectation is that the price goes up. And because it's a constrained supply, and so the pricing dynamics are totally different than manufacturing companies, where higher volume means lower cost. And as you are scaling up and capturing economies of scale, you're starting to drive down the cost that you can then transfer to your customers. And that expectation doesn't really exist in the mining industry. If you want more of it, it's going to cost more. And so that incentive misalignment was a big one that jumped out, and that only really kind of starts to come to the surface when you start to actually engage with the mining companies. But what fascinated me about the mining industry is that you are effectively solving problems at micron scale to start. You have to figure out how you extract. You have an ore that has 1% of a target metal, and you are trying to figure out how do you extract that 1% and get it to 100% purity. And that fundamentally starts at the atoms. And then you have to take a process that you develop that is at starts at micron scale and then deploy kilometer scale infrastructure. And going back to the thing that was exciting, which is scale, is that opportunity to work across those scales, which is exciting.
Something I always found interesting about Tesla, especially early days working with Panasonic, that a lot of the know-how, the process knowledge came from Asia. Spending a lot of time in Asia, just be curious, culturally, and just looking at scale as they sort of built out a lot of the early battery ecosystem, and then farther upstream. What did you see there? Is it just more chemical engineers? Is it more support for that industry?
Yeah, I think in the battery cell world, the precision at which you need to manufacture the product, like the tolerances on the final battery cell, require kind of a level of rigor and attention to detail that does come out in that does have a cultural aspect to it.
Like semiconductors.
Yeah, exactly. And so that was a big one. But also, it's a long-term investment. In Japanese, it's kaizen, right, where you're gradually improving over time. And in those super high precision, super high throughput industries, taking big swings where you make a radical change to one unit operation, that didn't really happen in those companies. It was much more of an iterative improvement to the systems that fundamentally eventually enabled you to get costs down. But yeah, the labor pool is a big piece, and I think that some of it is definitely cultural.
Your time at Tesla, Tesla famously vertically integrated very early. You're building a vertically integrated mining company, which we'll get into more details about later. But what did working at Tesla teach you about vertical integration and why it matters? Yeah,
I think as we started to scope more and more vertical integration, even outside of the going further upstream in the supply chain, the thing that's really interesting about vertical integration is you fundamentally are thinking about the incentive structure that exists between kind of yourself and a partner. And so Tesla had to vertically integrate early because people just weren't making the parts that were needed. It was a do or die. There was no incentive. There was no market for people to build the kind of subcomponents that were required. And so ultimately Tesla had to vertically integrate from day one. And then the things that pushed increasing amounts of vertical integration ultimately was the incentive structure misalignment, where suppliers and partners weren't incentivized to invest and scale at the rate that we wanted them to invest and scale. They weren't incentivized to innovate at the pace that we wanted them to innovate. And so you end up kind of insourcing a lot of that development that enables you to get to the product specs or the component specs that you want. And then it takes a lot of guts. Because at the end of the day, when you vertically integrate, you are transferring the risk profile of your partner kind of into your new expanded risk profile. And so you need to be really confident, or at least believe that you are better positioned to kind of take on and manage that risk profile.
When you were at Tesla and looking at and developing relationships with all these global mining companies, as Tesla was scaling and looking for suppliers, what were some of the key issues that you noticed from a market perspective? And then ultimately what sort of led to Tesla pursuing sort of further vertical integration?
Yeah, I think the incentive misalignment piece that between the industries and between kind of a commodity industry or the mining industry and kind of the manufacturing industry was the big misalignment that existed between the industries. The degree to which automation was absent was pretty interesting. There's a long period of time where mines make no money. Right. And so a lot of capital goes into the exploration phase, it goes into the development phase. What a lot of people don't realize is that when you start the mine, there's actually sometimes years where you are just getting through the waste to get, or drilling a shaft to get to the ore deposit. And so any additional capital intensity associated with automation kind of oftentimes the capital starts to get tired. And that additional automation equipment kind of falls by the wayside. And if you have the people there that can drive the trucks or drive the excavators or run the drill rigs, you'll take that. And we're at this interesting inflection point now where those people are less and less available. The mining industry has kind of been taking it on the head for a long time. It's not been a sexy industry that everyone wants to go into. And so the labor pool is contracting, it's shrinking, and it's both the trades and it's the engineering skill sets. And that the first things that mining companies say now is that the labor pool is one of the biggest challenges that they're trying to solve for. So that was apparent. And on top of that, these mines are not exactly in downtown Manhattan. They are in remote locations that.
Well, where have you gone? You've been on site before?
Yeah, of course. Indonesia, Australia.
What is it actually like? People see pictures, but like, what is actually going on?
It's a lot calmer than you might expect. Like you're usually working a couple of faces, and you have excavators or front end loaders that are picking up dirt. They're taking them to the unit operation, and it's not as rambunctious and crazy as you might expect a mine to be. And that's in Australia and in Canada. Like it's not this like buzzing atmosphere. In developing countries, it's a little different. There's like a different degree of, there's definitely a different degree of automation. Like, obviously we've come a long way from people with picks and shovels. And so when I say automation is absent, doesn't mean there aren't like heavy haul machinery that is driving around the sites. But there's a lot more kind of people activity when you go to operations that are in Indonesia or in Africa. And so, but yeah, been to most continents.
Why did you leave Tesla to build Mariana?
I spent a long time kind of like building businesses within Tesla. Was early on the cell manufacturing side, was early on the cathode manufacturing side, was early on the refining side of things. And what really excited me was always pushing further and further upstream. And I do think that we are at this critical inflection point where not only is the labor pool going in the opposite direction of demand in the mining industry, but AI and ML are getting to the point where, and it's not that it hasn't been that long, right? Like the AlphaGo moment was kind of in 2015, 2016. And people were using reinforcement learning to like, kind of like, there's a paper from 2008 on reinforcement learning for like helicopter control. But we're at this point where kind of like the compute and machine learning, reinforcement learning do really enable you to go no humans in the loop and how a lot of these plants are controlled. And as you like build more of that large scale infrastructure and kind of like see the problems that humans have to solve on a daily basis, it becomes like pretty obvious that these are problems that humans aren't best positioned to solve. Like these are large multivariable optimization problems that RL is like perfectly poised to solve. And then on the construction side, that is like an entirely different story. I think construction, there's a lot of workflow automation opportunities, and there's also tons of menial tasks where people are fat fingering data between databases. The data systems are completely disaggregated, and LLMs are presenting this opportunity where we can start to, and again, this is like a 2-year thing, really, and it's just going to get better. And so the opportunity to build kind of like from scratch, no legacy systems, and have some control over kind of like the destiny of the company that we're building. Like that's just an exciting opportunity.
What is, just a level set, like what is status quo in the industry today? Like what is like the BHP and the Rios of the world do for like a lot of like some of the stuff you're talking about, like from a software perspective, like internally?
They have digital innovation arms.
Yeah, they do have digital innovation arms. I think that the Freeports and the Rio Tintos and the BHPs, they outsource a lot of that. I think that they've like gradually started to like hire more and more folks that can do more internal things. But you have McKinsey, you have Palantir that basically act as consultants, and they will look at the large data sets and they'll kind of provide recommendations. Some percentage of those recommendations, oftentimes sub 50%, are taken. And what's interesting about what you want from the ML models or the RL models is that you actually want them to tell you to do things that are counterintuitive, because like humans are naturally going to find like a local optimal operating condition. And it's very risky to take shots outside of something that is currently working where there's $1 billion on the line. And that culture of like trusting the counterintuitive recommendation from the model is one that we want to try to build. And it's hard to build that within like large companies. I think on the construction side, when they build new projects, they're building $5-10 billion projects. And so they are always bringing in an EPC and kind of like throwing that over the fence to the EPC. And in the mining industry where, it is a bespoke plant, like it is custom, and you kind of need to think about the refinery and the mine and the processing facility as the product. And when you outsource that, you lose a lot of control of what you eventually are going to inherit and operate. And then EPCs, that model has shifted away a little bit from kind of like a turnkey, like we'll deliver you a project. It's kind of moved towards selling hours and like selling man hours and selling reports, especially in the mining industry, where it's like they'll do a pre-feasibility study, they'll do a feasibility study. And so there's a lot of over the fence and outsourcing that happens in the large companies. And some of that comes from like the talent acquisition challenge that the mining industry has faced over the last 20 years. Again, the mining industry has not been this magnet for talent. And what that means is that even if they are able to hire kind of like the best-in-class machine learning engineers and the best-in-class software engineers, they're not going to stay. They're going to like run into the wall of bureaucracy, and they're going to have higher paying opportunities in SaaS, fintech, ad tech, and they're going to go chase that. And so it's not just attracting talent; it's retaining talent. That has been a big challenge in the mining industry, and that forces kind of like an outsourcing of a lot of the core things that should be core today.
I mean, and we've seen this from the investor side. Like there are a lot of really exciting new technologies being developed for mining, and a lot of incredibly impressive startups that are building for, various pieces of the mining lifecycle journey, whether it's autonomous vehicles or drilling or, other various software and hardware tools for mining. But the challenge seems to be like, how do you get these kind of calcified large incumbents who operate in a very decentralized way, have very low risk appetite, and not a strong internal culture or affinity for tech. Like, how do you get them to adopt them quickly? Like, if you're a young startup, you're sort of at the beck and call of this behemoth, and you have very little control over your own destiny, which I think has made it really hard for tech to kind of penetrate this market up until now. That's at least what we've observed on the VC side.
Calcified is a good word. I think the way that this is construction companies and mining companies and really a lot of big companies, is that the way that they'll identify and evaluate risk is fixing the status quo or making like a step change improvement in the status quo kind of requires doing like 1,000 things. But you'll evaluate risk on each individual thing of that 1,000 things. And the downside of each individual 1,000 things is that the plant goes down, which is a multi-million-dollar event. And so you're really not incentivized to change things. Like even small changes could result in multi-million dollars of loss. And you need to kind of like approach it of like, how do I do the 1,000 things all at once so that I'm not stacking incremental returns on innovation with the same risk every single time? And that's where kind of like spot technical solutions are challenging to sell into the mining industry. And they'll do pilots. They'll definitely do a pilot. Like there's no skin off their back to do kind of like a pilot. But you'll end up doing a lot of pilots. And because they don't build enough plants kind of sequentially, like they'll build one big mine every 5 years, if that. And there just aren't a lot of opportunities to get into a commercial scale application. And if you don't time it perfectly, where like your pilot plant was 5 years before the commercial scale plant was planned for, like you're not going to be in that one, so you'll be in the next one, which is 5 years later. And so the pace at which the industry moves in terms of like deploying commercial scale infrastructure means that there just isn't a lot of opportunity to get new tech into commercial scale applications. And so there's a lot of folks that are doing like SaaS products, which is kind of the lowest cost way to get into to like generate uplift in a mining project or a minerals refinery. And the like barrier there is ultimately how do you get the operators to trust the recommendations from this SaaS tool from this small company that is trying to kind of tell you how to run a plant. And the culture is typically like, don't touch my things, don't touch my cash register, and like, what do you all know about running a mine? And it does stack up, and it makes, I've been calling it a death spiral for a lot of the folks that are trying to sell into the mining industry, because it's hard.
Just to like step back a little bit on the geopolitical context, like the stuff you're describing, I think very obviously true with a lot of the Western companies, but at the same time, a lot of Chinese companies that have sprouted over the last 20, 30 years have grown rapidly. Curious, why do you think that is?
Yeah, I mean, I think that there's like a lot of top-down and early recognition that critical minerals were going to be critical and needed to be supported. And so like shouldn't kind of like everything around policy and everything around kind of like supporting companies to go and deploy both infrastructure domestically and infrastructure internationally to kind of like secure critical minerals, build infrastructure that secures a position, like that has definitely happened. But I think that what people often don't talk about enough is that the talent pool is insane. Like it is not just a large talent pool. It is a large, skilled, experienced talent pool. I was in Indonesia in February and was kind of visiting one of the recent Chinese nickel refining operations. And so they buy ore. They also have some mining operations. But they had 13,000 people on site during construction and commissioning. And, if we were building a refinery in the US, which we did, it's hard to mobilize, a tenth of that realistically. And when you have, it's not just about the number of people, it's about being able to iterate on every individual work front as fast as humanly possible. And we just don't have that label.
15 years ago or 20 years ago, would the same companies that were big now have been big then? Like where's kind of the evolution of the space a bit?
Yeah, I think that there's been like a clear splintering on kind of who does the exploration and who does the development. Like right now, the industry is set up where junior mining companies, which don't mine, they explore, go and they kind of, they sometimes get, they'll get maybe a resource from a major mining company that's like held it in their portfolio for a long time. But it's like a different risk reward profile than what the mining industry is ultimately, like the mining majors are ultimately looking for. And so you have this junior mining ecosystem that sometimes is well funded and sometimes is competing for capital with like the cannabis industry in Canada. And they're taking shots in the dark, basically and there's a lot of work that's going into trying to make that exploration activity more intelligent, streamline it, drill less exploration holes while still being able to like interpolate or extrapolate what is in between those drill holes. But it's you're going out in kind of the middle of nowhere. Either it's really far north in like the Arctic Circle or the Yukon, or it's overseas in Africa and you're doing exploration, or it's in Southeast Asia or in South America. And those folks, like they have one job, which is to define a resource and pump up its value sufficiently to flip it to a major. And there's a lot of companies that aren't able to discover a resource that is either large enough, because the big mining companies, like they want to deploy large amounts of capital. We're talking about like multi-billion dollar investments. And so they won't really look at projects that don't have the scale that kind of enable them to underwrite their own inefficiency. Like they want to build really large infrastructure that enables them to capture the economies of scale. And so there's actually a really long tail of mining projects that don't have the scale that would justify getting acquired at a major premium. And so they'll go into this kind of orphan period, is what it's called in the industry. And it's hard for them to break out of that orphan period. And that's kind of where we see our ability to kind of step in as a more efficient builder and operator, is kind of take these, what the industry calls subscale assets, but we see metal there, and come in and like bring those into production as we kind of are building the platform, and then eventually scale into the same scale that the big mining companies are operating at.
Your thesis being that you can get the metal out and process it into a product that you can sell more efficiently than the majors, such that it's economically viable
to offset the scale advantage. Yeah.
Well, maybe then I think this might be a good opportunity then to talk a little bit more about like what is Mariana's product. Like you said a few minutes ago, you're not a SaaS product. What does it mean to be a diversified metal and minerals company, technology-enabled mining company? Like take us in a little bit more detail.
Yeah. So we're a vertically integrated software-first minerals project developer and operator. And so we focus on the back end of the minerals value chain, which is actually doing the detailed engineering, getting through the permitting, building the asset, commissioning the asset, and then operating the asset. And going back to some of what we were talking about around the labor pool, like those labor pool shortages exist in construction and they exist in mining. Like they're felt very, very intensely. And so our fundamental thesis is that with a contracting labor pool, you have to start with an awesome team. The table stakes is that you build an awesome team. But how do you enable 200 people to do what 10,000 people are needed to do today? At least on the like parent co side of things. And that comes from leveraging the recent advances in LLMs to automate workflows in the construction side of things, and the engineering side of things, and the procurement side of things, which take an insane amount of time. Like it's you make a lot of lists and you fat finger a lot of data between databases. And that is all about reducing churn in construction. I think that there's churn and latency. Latency is one thing that I think people sometimes don't appreciate from like status quo construction, like large scale mega projects, is that what's happening in the field and what the back office kind of sees, or what the executive team sees, or what the project director sees. There's like a 3-week lag generally for like really large construction projects, where you are trying to aggregate data from all the different contractors, all of the different and all the different parts of the facility into a consolidated integrated schedule, which you can then make decisions off of like, how do I prioritize what I'm doing today? And the way you run from on those, like in between those 3 weeks, is people stand in circles every morning and they say, what are you doing today? What are you doing today? What are you doing today? And they go off and they do the thing. They'll send like a very brief kind of progress report back. And it takes a long time to then take those progress reports and actually measure progress so that you can reevaluate priorities and understand kind of like how the project is trending. And so we're really trying to accelerate and democratize access to data fundamentally, and run construction projects like manufacturing facilities. And it starts there. And the reason construction and mining are so kind of integrated, and some people might disagree with me, but like a mining project is a big civil construction project. It just never ends. And, or you hope
it's more like a deconstruction project.
Yeah, that's fair. You are, well, you do when you're,
I guess you have to construct piles.
And you're building piles. And,
okay.
But there's actually a lot of similarities in kind of like just moving the dirt for like site prep. And the same kind of like software stack that is enabling you to get feedback from the field live is the same thing that the mining industry struggles with. There are mining companies will lose equipment, like especially in underground mines that are like these like deep mazes, and the industry is getting better at having like actual location sensing on like where the equipment is. But losing equipment in a mine is like it used to be a super common thing. We start with construction, and then we start to get into the second core software stack is what we're calling Plant OS. The construction stack is Capital Project OS. And Plant OS is really aimed at removing humans from the loop and deciding how the chemical processing operations and the refining operations work. And these are like big refineries are effectively big robots. You have the sensing and telemetry, you have the actuators to control how the plant operates. And, imagine like teleoperating humanoid robots like forever. Like that is what the refining industry and the processing industry has been. And there's obviously like PID control loops that kind of like maintain set points. So you can maintain temperature automatically, maintain pH automatically. But the thing that really matters is that the feed material to the processing facilities is constantly changing because the mine, like the ore body is changing over time. And so the way that the industry manages that today is they will blend the feedstock to minimize variability that's going into the processing facilities. And that enables them to minimize the amount of change that has to happen on a processing facility. So we're trying to flip that and say, okay, if we build a hyper dynamic and highly flexible refining circuit, ideally without adding a whole bunch of cost, what does that do to like optimizing the global operation from the mine to the refinery? But it's first aimed at reducing reagent consumption, reducing energy consumption. And Google kind of proved this. They bought DeepMind in 2017. And one of the first things they did was, throw the DeepMind team at automating and optimizing the data center thermal systems. So air handler, chiller, cooling tower. And that's not a super complex system. You have weather, which is a factor. You have loads within the building, which is a factor. But you ultimately have like 9 control variables between airflow rate, supply air temperature, the cooling water temperatures and flow rates, both in the chiller system and in the cooling tower system. And that just in that relatively simple system, they were able to reduce energy consumption by 30, 40%.
Yeah, it was like 40%. Yeah.
And it happened relatively quickly. And so that's the opportunity when you remove humans from making the decisions on how kind of like these process systems operate. Like that's the opportunity. And then when we look at kind of refining and processing facilities, that's like 1,000 control variables. And it's no longer single pass, because what's really interesting about minerals refining is that you never want to lose the metal, right? Every piece of metal or every atom that you lose kind of in the processing facility is another atom that you have to mine. So recovery in the refinery is actually like the biggest lever when it comes to cost. And so what that means is that the upstream unit operations, think of a refinery as like 20 unit operations kind of all in series in a relatively simple refinery. The upstream operations...
Relatively simple.
Yeah, right. The upstream operations obviously impact the downstream operations, because if you're changing the process conditions in the upstream operation, that changes what the downstream operation is seeing. But the downstream operations will recycle the like reject stream back into the upstream operations. And so it's this big interconnected web where if you make a change in one part of the circuit, and it's a high latency web also, where if you make a change in one part of the circuit, you may not see that change cascade for another 24 or 48 hours. And when we're commissioning refineries like the world, that like latency ends up being a major driver of kind of the time it takes to bring a refining operation to spec and then eventually ramp it to throughput.
So how long does it take to commission a refinary today?
I mean, there are some refineries that were built recently that are still not commissioned. That were built in 3 years ago. But the Chinese companies are doing it in like 6 months. And a lot of Western companies it takes 2 to 4 years. And that stacks up where we need to build like an insane number of mines and refineries. And if you are kind of 4 times longer or 5 times longer every time you build a refinery.
At every step of the process.
Yeah. And so we're trying to bring down the time that it takes to bring the refinery to spec, basically throughput and hitting the kind of like output requirements of the product that you're making. And then ultimately you start this like historically very long haul of gradually bringing down the cost over time. And that's something that we think that reinforcement learning is going to do quickly, much, much faster, kind of like in line with what Google demonstrated with the thermal systems and data centers, is, achieve global optimal operating conditions, on an order of magnitude faster timescale.
So how do you think about like you're building a company that mines and refines a product? There's a lot of tech that you can interject at essentially every step of that process. Like, how are you deciding what to build, where to partner? What are you developing in-house versus, where are you going to market?
Yeah, I think we're at the beginning, we're focused on how do we take kind of commercially demonstrated unit operations and be a better integrator and a better operator of that integrated circuit. And so focus on the software systems that enable you to kind of control the plant more optimally. And that's generally what project level financing parties want to see also. Like it's hard to get project finance on a first of a kind facility where you're demonstrating a new unit operation for the first time. And so we think that as we're kind of entering the market, the right place to start is take commercially demonstrated individual unit operations that operate globally, and try to go after the uplift that's available just by being a better integrated operator. There's a whole bunch of bottlenecks in building these facilities that we will need to solve. I mean, the like industrial supply base just for like manufacturing tanks is broken. Like there's specialty.
No. That's a new one.
It's just like things that we kind of take for granted, just take a really long time. If you want to kind of not go to China for sourcing that equipment. And that has a big impact on the operating side of things too, where the supply chain for like a new pump in Australia could take 30 weeks, and getting that exact same pump, but with a mine in China, it shows up in a week or 3 days. And so like that entire industrial like equipment supply base we're going to have to look at some point. That's obviously a much bigger bite to go after like commodity equipment manufacturing.
You're not gonna vertically integrate to be a mining equipment manufacturing
company. I don't think so. I hope not.
You'll let me know.
That's right. Well, this is the kind of like, what is the incentive structure of the partners and the suppliers, and like, is it required or not? I think that there's a whole bunch of companies that are working on awesome, like novel process technologies that have not quite gotten over the hump, trying to sell to the big mining companies. And we want to be the customer that helps accelerate commercial deployment, and the partner that helps accelerate commercial deployment. And one of the big issues that comes up when you're kind of like deploying new processing technologies is that part of the reason why it takes a long time for it to get to the point where it's commercially viable, other than all the headwinds from the industry being conservative and process driven and all those things, is that humans have actually never operated that process chemistry at scale before. And so you'll learn a bunch of things at pilot scale, but pilot doesn't really tell you what's happening at
and you have
commercial
to train
scale.
people.
You have to train the people to operate it. It's like new environmental things that might come up depending on the chemical that you're using. And that like scale jump is actually something that we think that RL and will enable with like a pretty meaningful like pace adjustment, where you don't need the humans to kind of like fine tune the process conditions around a new process chemistry, because Plant OS is doing it.
Ryan and Erin, how did we approach this industry? Is this a space that we spend a lot of time thinking about, or think about opportunities in the space, or how did we approach it?
Yeah, we've wanted to do a mining investment for a long time.
Mm-hmm.
When you think about venture capital, we care about massive markets, and there's not that many massive markets left that have been sort of like largely untapped by technology, and mining sort of screams one of the largest markets in the world. Very little adoption of technology. So, over many cycles, we've gone out and spent a lot of time meeting companies. And, as I mentioned before, the challenge is, how do you sell a point solution or a point piece of technology into this industry that has very little incentive to adopt it, and is also has a very complicated geopolitical dynamic where you have a very large global player with their hand on the scale. We put out a piece a couple weeks ago around our thesis in mining and why we think a vertical mining company is the answer, because we actually do believe you have to control every single piece of the entire journey, the entire life cycle of, an atom of metal end to end, to actually be able to build a tech company here. This is not about, a point solution for one particular part of the process. In order to actually capture the gains and efficiency and build a feasible business, you really have to own the entire process end to end.
The only thing I'd add there is that this is the intersection of geopolitical urgency and tech. Like, to what stuff Turner's been talking about is like, now we have technology that can actually go and disrupt this. But also as a talent base, people coming from companies like Tesla, SpaceX, Anduril, other sort of hard tech companies working in sort of dirty spaces, willing to go out in the field,
roll up their sleeves,
go out in the middle of the desert and work on this stuff. So now's the time to build this company.
And the political tailwinds are there. There is, even my conservationist mother, who I think if like we had this conversation 5 years ago, she would have clutched her pearls. She doesn't wear pearls, but she would have clutched her pearls at the idea of domestic U.S. onshore mining. I think broadly speaking, the American public and certainly the government has come around to the idea that metals are in every single thing we use as consumers. Our supply chains are highly reliant on China. It's a huge problem. We have to figure out how to address it. And that means investing in mining in the US again.
We talked a little about, we mentioned like rare earths, you mentioned lithium and things like that, but like there are many different critical minerals. You talked about a little about in the very beginning, but specifically like what are the interesting ones for you? How does that map to sort of what people see on the headlines and what the business opportunities are?
Yeah, I mean, when we look at what needs to happen in the next 10 years, and forecasted demand will only materialize if the supply is there. So we'll see if that forecasted demand materializes. The metals that actually need to grow the most by like mass flow rate are like the big metals. Like, we need a lot of aluminum, we need an insane amount of copper, we need more iron, we need more zinc.
What are some of the things that these these metals are in?
Yeah,
Just
sure thing. I mean, like iron goes in everything that is
Yep.
infrastructure.
We got iron.
We're
We're good with
cool.
iron.
Zinc is one that people sleep on because you actually have to galvanize a lot of that steel. And so zinc oftentimes kind of pops up every once in a while as being something that we really do need to continue to focus on. Copper is the workhorse of this push to electrify everything, and to just grow the grid to be able to supply AI, to be able to enable accelerated renewable penetration, for EV penetration to happen. Like, you're going to need a lot of copper. Aluminum is one that I think is underestimated. It's people underestimate kind of its importance. It's actually like the number one most consumed metal in defense applications. Like the grid is, people talk a lot about copper, but there's a lot of aluminum like conductors in the transmission lines that are critical to actually growing the grid capacity. And in automotive, obviously, aluminum's big. Magnesium has a whole bunch of defense applications, potentially could get more into automotive applications and like for lightweight metals. Lithium, needs to 4x in terms of production capacity in the next 10 years, roughly, in order for the batteries that we want to build to be built.
Well, we're all about batteries. So.
Right. Yeah. Nickel is a big one. I think that what has happened in nickel in the last 5 years is Indonesian kind of like production capacity has scaled to the point where it's now something like 70% of global nickel comes out of Indonesia. And a lot of that was on the back of like meaningful investment from China to be able to kind of expand production capacity in Indonesia, and then also do more of the downstream processing in Indonesia. And nickel goes into everything that is specialty alloys, anything that needs high temperature or corrosion resistance, and also is like kind of the unsung hero of high energy batteries, where these lithiated transition metal oxides, which are high nickel. Manganese is important. Manganese goes into a lot of alloys and also goes into batteries. The uranium, if fission is going to continue to grow and we're going to continue to like deploy more nuclear capacity in the US, then uranium is going to be needed. It's a long list, and the rare earths, they're important. Obviously, they are omnipresent in like everything that we use, but they show up as like a relatively small kind of like in on a volume basis when you look at kind of the stack of metals that we need to mine, and where definitely we need a ton of like process innovation in how rare earths are refined. Solvent extraction circuits are kind of like the status quo. The chemical intensity is high and the recoveries are relatively low, and the know-how is kind of like highly penetrated or highly concentrated in China. But it is a little bit of a frothy market right now, and so we're being a diversified minerals company kind of enables us to pick our spots in areas where it makes sense. Like these things still do move on commodity cycles, and you actually want to be building infrastructure at the bottom of commodity cycles, not at the top of commodity cycles. It's the Warren Buffett quote of invest when there's blood in the water. Like you want to be coming into metals when they are at like this trough, really, where no one is investing in them. They still have like a macro long-term critical point. Lithium is like exactly in this position right now. And that's why we're focused on lithium. Copper just has this like macro trend that is like pretty hard to ignore. We're just going to need an insane amount of copper. Copper grids are going down globally, and which means that our ability to extract copper from those ores is going to get harder and harder to extract copper from those ores, and that's where the Plant OS side of things, we have like a high degree of confidence that we'll be able to step in and kind of like optimize the refining circuits to still be able to extract copper from these lower grade ores without seeing meaningful kind of cost increases.
So everyone knows, people here, it takes forever to get a mine started. I don't know how many new greenfield mines we've developed in the United States in the last decade.
Not many.
Yeah. So like, and I know Australia and Canada have been able to do this faster, which is interesting. You don't know Canada for moving quickly. What are some of like the bottlenecks there? What does America need to do to accelerate this as one of these companies trying to not only mine but also refine in the United States? Like what needs to be done?
Yeah, I think one thing that folks don't always see is actually the permitting requirements for exploration. So there is like, if you are exploring over on federal land, if you're exploring over more than a 5-acre parcel, you have to submit like a plan of record or plan of operations that needs to be approved by the BLM before you can start to expand and explore over a larger piece of land. And so the like bringing down the permitting thresholds and the permitting burden associated with exploring, like that is why we have such a small, like relatively small rare earth resource. It's like, it's not because there isn't, like the US has tons of natural resources, and the kind of like USGS estimate for US, like the US reserve on rare earths, just picking on that, like that is tied to lack of exploration activity, not necessarily fundamentally like a lack of kind of like geologic
we haven't
presence.
looked for it.
Yeah, we haven't
That's
either. We
kinda
haven't
hard
looked
to
for it, or
find,
it's
or-
yeah. Well, it's hard to find in like high concentrations that are mineable, which we're trying to kind of like drop the percentage requirement that makes something economical. But it's also, there's just a lot of like kind of like permitting burden to be able to actually go and deploy drill rigs to go and actually explore. And then there's definitely the government currently is doing a good job of kind of highlighting the importance of the minerals industry. And you're definitely seeing like a little bit of a tone shift over the last 20 years that is much more supportive. There's way more tailwinds when it comes to kind of like making mining be viewed in a more positive light and a critical light. And that will help to solve some of the talent pool problem, where people that are, you know, awesome, they want to go build things. They don't want to go and like work on a project that kind of sits around for 5 years and maybe gets permitted and maybe doesn't. Like they want to go work on hard problems where they can see the impact of the work that they're doing. And so if we're getting in the way of enabling projects to get built, like that is actually a major deterrent for talent, because they won't actually see what their like the like output of their work. And then I think the permitting requirements broadly for going from a discovery to an operating asset, there should be a big focus on kind of efficiency in reviewing environmental permits. There should be a big focus on kind of like streamlining those workflows and the back and forth between kind of like field offices and state offices from the BLM, just focusing on the federal side of things. Because the way that projects get permitted right now is you'll throw like your environmental assessment over the table, and then they'll go and they'll divvy it up between a whole bunch of experts that they are like kind of consultants that they bring in to review the permit. And they'll get back to you eventually at some point. But there isn't a lot of visibility into like how they are progressing with reviewing the permit applications. And discussions are getting more bilateral. And again, there's been definitely a change with the new administration where there's a little more accountability on the permitting offices. But there's tons of room for making those reviews more efficient. And again, LLMs will make it more efficient. We just need to kind of like penetrate that side of the federal bureaucracy and like enable people to review things faster.
What else, aside from kind of permitting efficiency, what are other things that if you could send a list of recommendations to the government for what they should do to support the U.S. mining industry, what would be your top 3? Yeah,
I think supporting the demand side is probably like the biggest lever. And if you want to mobilize kind of private capital into the sector, having some level of support on the demand side is major. And so that's offtake agreements with floor pricing. And, they did this just now with MP Materials. And that, ideally provide some stability on the revenue side of things so that investors there's trillions of dollars of capital kind of like dry powder just sitting around waiting to be deployed. It has historically kind of avoided the mining industry because of the market price uncertainty. And so as soon as you provide, it's a commodity cycle. And like, what if you're building at the wrong time? And, the infrastructure funds are not the ones that are here to play, like be intelligent about the commodity price cycle. Like they're looking for annuity type returns. And so those folks would mobilize if there were more demand side support from the government, either providing price floors or fixed pricing for critical minerals that you're trying to incentivize more production of in the U.S. Participating in the capital stack is important. I think lowering the hooks or the extra burden that comes in with receiving government funds is important, and like some government agencies probably have more leeway to do that. Like the DoD, obviously, again, just did this big deal with MP Materials, and actually went all the way to kind of participating in the cap table, or as an equity holder. But when you receive federal funds from the DOE, or if you receive federal funds from like on the debt side of things from Ex-Im, it comes with some like additional burden sometimes. Like if you are building on state land and you just need a state permit, and then you bring in federal funds, you now bump your permitting requirement to a federal level permit. And that's the NEPA process, which, again, the NEPA process wouldn't be as burdensome if there was some more efficiency on the permitting side of things.
Mineral deposits, specifically like high grade mineral deposits, don't obey borders. Like, is there a broader international strategy here? I mean, I would love to think we can mine and refine everything in the United States, but obviously there's a lot. Australia, Canada, Latin America. Curious
Africa.
sort of what Africa, underwater, seafloor. Like what is the overall strategy in your mind?
Yeah, we're starting in the U.S. because it's closer to home, and we're focused on developing a platform that we can scale off of. But at no point have we told ourselves that the U.S. is kind of like the sole focus. Like you have to be able to like bolster the company to be able to operate internationally if you want to be able to scale beyond kind of like the resource base that the U.S. has like available today. And so more exploration is going to happen in the U.S. We'll probably discover more resources, and like that pool will grow over time of projects that we can build in the U.S. But yes, we are absolutely going to expand overseas and underwater maybe.
When we look back a decade from now, what's the single clearest indicator that Mariana has achieved what it set out to do?
We won't be as worried about our ability to secure the critical minerals that we want to secure, because we will have kind of rebuilt and established like an entity, ideally, that is able to go across borders, to your point, and build these projects cost effectively, time effectively, and responsibly, ultimately. And the reason that we are so panicked about it right now is because we have fundamentally lost the ability to build large scale infrastructure, and we have lost the ability to like operate complex minerals plants. Like that's what we have lost. And we need to build that back. We want to build 10 projects in 10 years. Those projects will be an increasing scale over time, but the work will not be done in 10 years. What I think will have demonstrated that the 10-year mission will have been accomplished, other than building those 10 plants, is that we will no longer be as worried about like our fundamental capability to go and build this complex infrastructure. Like we will have unlocked it.